Today I'm going to talk about crustal-scale control on the evolution of the Yeneena basins. Yeneena Basin, let me to change. Okay, Yeneena Basin is a Neoproterozoic basin located at the northeast margin of the Western Australian Craton, and the major stratigraphic units are Pilbara sandstone and Broadhurst formation in Trossel Range group. And then when we have a Isdale formation, and in the Lamil group we have a Malu formation, Punta Punta, and Wilkie. The main issue about this stratigraphic unit was the extent and distribution of these units under the cover and the sequence and age of events, and also the relationships with Central and Super Basin. When we look at the Yeneena Basin, we see the northern part of the Yeneena Basin covered by Phanerozoic Canning Basin. But when we look at the gravity and magnetic, this cover doesn't look like it to be so deep. The main objective of our study was understanding the geodynamic history of the Yeneena Basin, and we start with remapping and reinterpretation of bedrock geological map, and then we follow our study by doing some geochronology and isotope analysis, and finally we wanted to do some numerical modeling based on the conceptual model. In this talk, I just talk about the remapping and reinterpretation of the bedrock geology map of the Yeneena Basin. First of all, we choose some cores to have some idea about the major rock types in the Yeneena. And when we look at the Trossel Range group, we see we have a kind of Peritic black shales and Peritic black shale, and also in one of the cores we see some mafic dominated conglomerate and dark argillite with dolomitic intervals and hematitic alteration. Toward the Lamil group, we have quartzite and light gray sandstone, and in some part we have a kind of interbedded sandstone and siltstone. Toward northeast, the metamorphism grade is higher than the other part of the Yeneena, and in this area we see some biotite schist with granite and dolerite, and undercover we have mainly pessamite and metaphylites and granitic rocks. When we look at the high logger data, we understand the mineral assemblage of cores are different based on the geophysical domain. For example, these two cores are located in the Trossel Range and high magnetic rocks, and they have a similar mineral assemblage considered as a Broadhurst formation. EPT 2193 considered as a part of the Broadhurst formation, but the mineral assemblage is completely different. We have a high level of carbonate content. When we look at move toward the Lamil group, we see in one of the cores we just have the quartz, and because of the sandstone and quartzite, but in the other part around here we have a high carbonate content. And when we move toward north, the mineral assemblage is completely different from other part of area. Also, we measure some petrophysics data, and we see that the magnetic susceptibility of rock is completely different from each other. For example, Malu formation has a very low magnetic susceptibility, and the Broadhurst formation has a high magnetic susceptibility, which is different from EPT 2193, which is supposed to be Broadhurst formation. On the other hand, we have a Punta Punta formation here with a high magnetic susceptibility, which is again different from the Malu formation, and it's very similar to the rocks on the under the cover zone. So we try to integrate the petrophysics, high logger data, and and geophysical interpretation to understand the extent of the major stratigraphic unit. And here is the geophysical interpretation, all of the structures, geological boundaries, and geophysical trends. And when we look at the major structures and rock types, we see that Pilbara Craton, granite and greenstone of Pilbara cut off by Wines Fault. It comes down through here to Marlow Fault. Then we have a Southwest Trust and Mackay Fault, which separate the Rudall Province and Yeneena Basin from the Officer Basin. We have a West Australian Fault at the edge of the Wakarli sub-basin comes down through here and linked to the Camel Tabletop Fault and Maroochydore Fault. And on the other side of the Wakarli sub-basin, we have the Ancatel Samphire Fault, which comes down here and also show offset from the Polar Range Fault. Polar Range faults separate the Lamil group from the Trossel group and extend and these are the major structures that control the Yeneena Basin. Based on the stratigraphic unit, we have a Tarquinio group here. It's part of the Officer Basin, and it's considered as a supersequence one of the Centralian Super Basin. It's basal siliciclastic rocks of the Tarquinio group overlaying the Archean Fortescue group west of the Wines Falls, and it also has some shallow evaporite and carbonite and with stromatolite. In the magnetic aeromagnetic data, we see a transition from low magnetic rocks of the Tarquinio group to the high magnetic rocks of the Broadhurst Formation, which is black shale. Black shale considered as a deep water basin floor sediments, and consider these Broadhurst as or Trossel Range rocks as a kind of a lateral equivalent to supersequence one of the Centralian Super Basin. The Trossel Range group rocks are located mainly between Wines Fault and Parallel Range Fault. Its basal unit, Culboro Sandstone, shows a low magnetic signature, overlies the Rudolph province, and it's overlain by black shale of the shales of the Broadhurst Formation. Isdell Formation is mapped between Parallel Range Fault and West Wakarli faults, and then after parallel range faults, we have a Lamil group which extends toward north. Here in this slide, you can see the relationship of the Trossel Range group rocks. You see that the low magnetic rocks of the Culboro Sandstone covers the Rudolph province and is overlaying the Broadhurst Formation. And here is the only place that Isdell Formation is really mapped, and we can see the boundary between Isdell Formation and Broadhurst. And we can see the folding and refolding of Isdell Formation in this slide. And here you can see that Isdell Formation is overlain by the Lamil group, including Punta Malu and Wilkie Formation. And you see the this highly magnetic marker at the base of the Wilkie Formation. And also we can see in granitic rocks in the middle of the Telfer Range group. Toward the north, we have we can trace the high magnetic rock of the Punta Formation and the marker unit of the Wilkie Formation in this area, and some granitic rocks. Based on the structural evolution, there is still some issue that we need to work more on it. But at this stage, we understand the nifty copper deposit considered as a Cindy formation deposits, sedimentary hosted Cindy formation deposit, and it is dated around 800 million years, and it can be related to the mafic intrusion in place during the basin extension at 830 million years. Also, there is a dextral transpiration occurred in this region at 800 million years. After these events, we have a kind of southwest directed thrusting during the Miles orogeny, and during the Miles orogeny, it causes intrusion of the Mount Crafton granite and copper and gold mineralization. If I wanted to summary the events, we consider firstly we have a supersequence one as a site basin, and then we have a large igneous province around 830 million years, which can be considered as a source for copper mineralization. Then we have a syndextral transpiration because the nifty mineralization. Then we have a southwest directed thrusting because intrusion of the Mount Crafton granite and gold and copper mineralization. And finally, we have a Paterson Orogen at 550 million year reactivation of southwest directed truss structure. And then we have a Karenji, a large igneous province at 500